We're now going to be going into Code Wars. Code Wars is an excellent resource. It's a way that you can get lots of sample problems. They run tests on the problems. And after you solve the problems, and you can look at the solutions created by other people. So the learning experience is not just in actually getting the code challenges, but also seeing how other people solved it, and what did they do? How do their solutions differ from yours? Sometimes they're using some really advanced solutions. Sometimes it'll be stuff that may look similar to your code, but having a community really helps you to get a perspective into your code and how it works in the context of how other people solve it. So let's just take some random stuff off of Code Wars. So we're taking some of the Code Wars. When you come in, just go to codewars.com. You have to walk through their whole process, and it'll start taking you through challenges. You choose a language, which we've chosen JavaScript, and we've chosen fundamentals here. And when you go through, you have ranks. So the KYU, that is the rank. It starts off at rank 5. 8 is the easiest, and then 7 is the next hardest, and then 6, 5, 4, 3, 2, 1, whereas 1 is the absolute hardest. So we'll just do all 7 8s here in this training. So this particular one, this looks good. This just randomly came up on my dashboard, so I'm going to go ahead and do train. And what it'll do, it'll give you your instructions, and then it'll tell you what your output, is. But here are your instructions, your solution you type here, and there are some sample tests. And so when you're done, you can press test, and then attempt when you're ready to finally finish. So let's just go over this. And let's take we'll do the first one in the REPL, since we've been working on the REPL up to this point. Actually, I changed my mind. I think I want to do it right inside of here, just for the sake of time, because you should be able to figure this out, because it looks very similar to some of the other challenges we haven't learned. So we'll just go ahead and keep it in here. Okay, so what are we doing? Trolls are attacking. So it's called disembowel trolls. So the trolls are attacking your comment section. A common way to deal with this situation is to remove all the vowels from the troll's comments, neutralizing the threat. Okay, sounds like a cyber attack. Your task is to write a function that takes a string and return a new string with all of the vowels removed. For example, the website is for losers. This website is for losers. Yeah, that looks like a troll would post something like that. Would become, this website is for losers. Instead of LOL. All right, note for this kata is Y is not considered a vowel. Okay, so accumulator patterns, right? So we talked about this before. Let's actually put this to use. I'm going to just make this a little higher in terms of the resolution. And when we're ready, we can just go down and just do a test. All right, so what is the input? It takes in a string, which is this. What is the output? It returns a new string. So in an accumulator pattern, we could loop through this string and then return a string that had all of the, all the vowels removed. So one of the things that we talk about is pseudocoding, and this is something that we could actually start doing right here. So what would the steps be? The first step could be to define the vowels, right? Because we got to remove vowels, but how do we define them if they're not, we don't know what they are? Then the next thing we may want to do is loop through the string. We'll say loop through the string, and also defining an accumulator up here. And then this accumulator would just be an empty string. That's super important, because here we can loop through the string and add non-vowels to accumulator. And then finally, we can return the final string. Okay? Simple enough, but that pseudocode really does help us out a lot. It helps us really organize our thoughts. So the first thing we want to do is define the vowels. So we can say, we could use const or var. So var vowels equals A, E, I, O, U. And it said that Y was not a vowel as far as this is concerned. And then we want to define the accumulator. So var output equals an empty string. Most of the time, you don't want to define your accumulator inside of the loop because every time you loop, you would reset the accumulator. Okay. So now we want to loop through the string and add on the non-vowels. Okay. So we'll say for we can loop through a string because strings have indices just the way arrays do, right? And we want to say, we're saying that if it doesn't, if it's not a vowel, then we want to keep it. So remember we said that we had the array method of what? You can pause the video and try and remember what array method can we see if an array contains value. It includes, right? So say if not str, oh, not an array method, a string method, but string method also has includes. If not string, or no, we are talking about the array, it's the vowels, right? If not vowels, includes string at I. Here we've got the bracket bouncing again, right? So put this bracket here and it's balanced there. Then we create output. Then we talked about concatenating onto a string, adding onto a string. Output plus equals string at I. So adding onto it. Now, looking at our balanced brackets, here is the end. So this one here is unmatched. You see that? So we have to put here to match that. Now this here is the end of the for loop, and this is the end of the function. So the balanced brackets really help you, right? And then so in here we have to return the final string. So we want to do return our output. Okay, so now we want to test it. All right, what did we do wrong? Expected this website is for losers, LOL, to equal. So we didn't, you see what happened? It took out all of them, but it didn't take out the O. And why would that be? If we're removing A, E, I, O, U, right? Why would it not take out the O? Well, if you think about it, this O is a capital O. So now we could add capital A, E, I, O, and U to there. But what if you didn't know? What if there was a way and you weren't quite sure, but there was a way that we could just flatten everything to be a lowercase and just deal with lowercases, right? So we could say that if we could actually make a new variable for var lowercase letter equals, and let's say you didn't know the value, you could always go and Google, how to make a lowercase, how to make a vowel lowercase. But in this case, when you look it up, then you would find out, say, vowel lowercase letter equals string at I dot to lower case. And then we're going to compare string at compare the lowercase letter. And now when we run the test, you see that it passes. Okay, so I don't want to gloss over the problem solving process of this because that's a real key critical point, and a lot of this just comes from practice. But when you analyze, it's really important when you analyze and see the, let's just take this out again. Reading errors is probably one of the most fundamental things. Is saying expected, just like in our assert equals methods we've seen before, if you've done the test driven stuff before. But if you haven't, usually there's an equality that's being assessed. Expected this to equal this. So you look at, theirs versus yours. Theirs versus yours, and you look at the difference and you say, this is, expect this to equal this. So when it says to equal, this is the target. So my target didn't look like their target. And that's why I had decided to just change everything to Lord. But sometimes if you really, if you didn't know to look, if you didn't know you could change things to lowercase, there's a dot to lowercase and there's also a dot to uppercase. Let's say you didn't know that that was even a thing. In a pinch, in an interview, you could always just add them A, E, I, O, U, etc. Now, and you could just add them there. Whatever it takes to get it done is valid. Don't ever be ashamed that you don't have the fancy solution. Okay. Now, of course, when we see the I've never seen this problem before, but when we get into it, I know that somebody's using a regular expression to solve this problem in 2 lines. But that's okay because you're just getting working it out. So we do attempt here. All 101 tests pass, and you can refactor, etc. Once it passes, a lot of times I'll take the comments and the pseudocode out, just because it should be self-explanatory, and other people may not want to read your comments. Clean it up a little. We do attempt, passed, and then finally you can just do submit. When you submit, then you can see other people's stuff. So yeah, see, they're using a regular expression and a replace, which is a string method called replace that takes a regular expression as an argument. What it's doing here is it's looking for all of the vowels, and then it's doing a global search in it's global search in case insensitive, and returning those with nothing, which basically removes them from the string. But again, this is not a course in regular expressions. This is a very elegant solution, but you can look at other people's code, and you might see some things that we used before, split and join. Higher order functions are a huge power tool that's beyond the scope of the tier 1 course, but I would use a filter on this. I would use the regular expression and a filter. Um, but these are examples of some different solutions. So yeah, so that's the beginning of Code Wars. We're going to do a couple more problems in the next clips, just so that you can get used to the cadence of solving these types of problems, and we can start using different tools.